Recording started.
Hello everyone, my name is Geoffrey Lokuta. I am the Tier 3 PineMAP Research Associate located at the University of Florida, and I'll be in charge of managing a lot of the measurements on the Tier 2 and Tier 3 components of the PineMAP project for our region.
Hi everybody, I'm Madison Akers, and I'm doing essentially the same thing as Jeff, but in the Georgia-Auburn region.
I'm Laviner, doing the same project management in Virginia for Virginia Tech.
So on behalf of myself and Madison and Andy, we'd like to join you all for another edition of the PineMAP webinar series. Today, us three are going to discuss the Tier 3 component of the PineMAP project, which is a precipitation fertilization manipulation study. So, a little roadmap here. I'm going to begin with the purpose of the Tier 3 and the overall objectives and direction we're going with the project. Next, I'll discuss its integration into the rest of the project, specifically Tiers 1 and 2, and how they all kind of interact with each other and build on top of each other. Next, I'll briefly discuss the 4 study site locations we've selected for the project. Before I turn things over to Madison, she will discuss the site and genetic requirements. I'll chime in one more time to discuss the study site characteristics. Madison will finish up with the study site climate profiles with respect to temperature and precipitation. Finally, Andy will finish things up. He'll discuss the experimental design of the project. He'll also discuss the Rainfall Exclusion design, some issues we've discussed, materials we've selected, etc. And finally, he'll close with the measurements we plan to take on the Tier 3 sites. So the overall purpose of the Tier 3 project is to manipulate climate by reducing precipitations, essentially creating conditions that are outside the historical range of climate variability of loblolly pine. By doing this, we're going to look at the effect of climate on productivity of these pines. We're going to expose the interactions between genetics, nutrition, and precipitation. As I mentioned, we're going to reduce precipitation. The value we've selected is 30% reduction, and this is based off what we expect is the predicted maximum variation in summertime precipitation. And likely with decreased precipitation, we're going to see differences in responses across nutrition gradients, and that's where our fertilization regime comes in. Also with reduced precipitation, we're going to see some soil water, or likely to see soil water and vapor pressure deficits. And these are likely to elicit physiological responses that are going to vary across genetics. So that ties in genetics. That's why genetic deployment and breeding programs are going to be important in the Tier 3 and overall PineMAP project. We're going to be measuring above and below ground carbon and nitrogen pools and fluxes, and we're going to ask questions like how these fluxes vary across the contrasting climates, geography, and soils of the different Tier 3 regions. We want to determine how the climate influences key ecophysiological parameters. For example, we're going to measure maximum intercepted photosynthetically active radiation, and we're also going to partition soil respiration to autotrophic and heterotrophic components. Finally, there will be a modeling aspect. We're going to verify and validate growth and yield models, carbon models, and also water models. I'm not going to go too much in this slide. You might have seen it before. It's actually from one of Dr. Martin's presentations. The overall point here is that Tier 3 builds on Tiers 1 and 2. While Tier 1 consists of 500 sites of permanent plots and growth and yield cooperative plots, we're only going to be collecting existing inventory data on these plots. Tier 1 is 140 sites of established field studies created by cooperatives across the Southeast located at various institutions. These 140 sites, we're going to measure inventory as well as carbon and nitrogen pools and fluxes and some ecophysiological measurements. Finally, our 4 Tier 3 sites, as I mentioned, we're going to manipulate the fertilization and also the precipitation. This will be the same as Tier 2 and Tier 1 measurements, and in addition, we're going to take more intensive carbon, nitrogen, and water ecophysiology measurements. Overall, the Tier 3 is going to build into the overall goal of PineMAP to increasing carbon sequestration and altering forest management systems to better face climate change. We have selected 4 locations for our Tier 3 sites, and they're going to be located at the edges of the loblolly pine range. These sites were chosen because they vary in potential productivity of pine and span their full temperature and precipitation gradients. In our ideal world, we'd like to have more than 4 locations, but due to personnel and budget constraints, we decided to focus our efforts on these 4 sites instead of selecting more sites than that and not taking as more intensive measurements on each of the sites. Our 4 sites selected, one's going to be in Virginia, one out west in Oklahoma, one in the south in Florida, and one either in the Alabama or Georgia region. So let's see if I can get this tool to work here. Essentially out west here is our Oklahoma site. It's located in the southeastern corner of Oklahoma. In charge of this region, both Tier 3 and Tier 2 measurements, is going to be the groups at Texas A&M and Oklahoma State University. In the south here, University of Florida will be solely responsible for the Florida Tier 2 and Tier 3 measurements. In the north, in the Virginia site, both Virginia Tech and NC State will be responsible for measurements. And likewise, in our region in Alabama and Georgia, Auburn and the University of Georgia will cover Tier 2 and Tier 3 measurements. Essentially, by dividing ourselves up, we're better able to manage things, but we will all be interacting and sharing our data and our efforts, working as one, but splitting into teams. So now I'm going to turn things over to Madison. She's going to discuss the site and genetic requirements that went into selecting these sites.
So the universities in each region were responsible for finding a suitable Tier 3 site, and it was decided that the site should be loblolly pine plantations and representative of the region as far as physiographic traits and soils. Uniform stand attributes and soil types across the site will make it easier to infer treatment effects, and a seed orchard mix of known genetic origin allows for broad inferences on loblolly pine, so the results won't be specific to any one family. Other requirements include sufficient acreage for 16 plots, which will then be divided into 4 blocks, and reasonable travel distance for everyone involved. We want at least 5 to 10 years of site availability for long-term research, and nearby power lines are preferred because we want to provide electricity for some of our measurement equipment. And we want stands that have not reached crown closure to avoid the confounding effects of competition-induced stand development changes early on in the study.
So it's Geoffrey Lokuta here again. So as I mentioned, we've selected several sites thus far. Our first site is the Florida location for the Tier 3 project. This is located in Taylor County, west of the city of Perry, Florida. The polygon and aerial image to your right shows or depicts the stand as the photo was taken, I believe, in January, so it's pretty up to date. This site is owned by Foley Timber and Land Company. The soils of the site are Melvina Mariah Lutterlow complex, which is essentially a fine sand. The Melvina belongs to the Spodosol order, while the Mariah and Lutterlow belong to the alpha-sol group. The drainage classes are somewhat poorly drained. The site it's about 8 years old now. It was planted in 2003 or early 2004, and the planting stock was St. Joe Company, second generation open pollinated stock. It was planted on 6-foot by 10-foot spacing. This mechanical site prep, I guess no is essentially lined. I'm sure it was probably raked, but it was. What I mean there is it was not bedded. The site was hand planted. I mean, not hand planted, but rather machine planted. It did receive some chemical site prep, although I'm unsure of the exact treatment. And an age 1 cruise, although a light sample, revealed 547 trees per acre. Our second Tier 3 location, as I mentioned, is in Oklahoma, in McCurtain County, which is in the southeastern corner of the state, west of the city of Broken Bow. The soil belongs to the oldest salt ore. It's a rustin, fine sandy loam of the well-drained drainage class. It's a significantly younger stand, planted only in 2008, so it's got some growing to do, but I think it's progressing along pretty quickly. The seed planting stock is representative of the region. It's planted with Oklahoma seed orchard mix on a 7-foot by 10-foot spacing. The site was not bedded, however, it was ripped. If you're unfamiliar with this mechanical site prep treatment, they essentially put a shank into the ground and fracture the upper 40 to 60 centimeters of the soil. This is often done when there's a confining layer or a rocky soil, and this will facilitate root penetration and allow it to get to deeper water depths. The site, however, was not machine planted in contrast to the Florida site. Again, it did receive a chemical site prep shortly after planting, and the current trees per acre are somewhere between 580 and 700 trees per acre. The aerial image to the right here is a little outdated. It's from 2003, so ignore the intense variability in the stand. It's quite uniform now, although I can't find any recent imagery. Our third location is located in Virginia. It's actually in the Appomattox Buckingham State Forest. It's close to the corner of Buckingham County, east of Appomattox, Virginia. The soils are Little Joe silt loam and Spears Mountain silt loam. It's also a well-drained soil. It has a similar planting date as the Florida location. It's about 8 years old, planted in 2003. It was planted with second-generation Piedmont orchard stock, 12 by 12 foot by 12 foot spacing. It did not receive a bedding treatment, but possibly it was probably raked or plowed. It was not machine planted, similar to the Virginia site. Shortly after planting in January, it received an aerial release with 8 ounces of arsenal and 1 quart of accord per acre. And after the site was selected as a Tier 3 location, Andy and the crew up in Virginia completed an understory control in 2011, several months ago. They added glyphosate, arsenal, and escort to cut down some of the smilax and the briars, and I think knock out some of the volunteer pines. And based on Andy's inventory, it's 325 trees per acre at this location. And if you remember from the map I showed earlier, there was no coordinates on the Alabama-Georgia location. They're actually still working on selecting a site. As Madison mentioned, we have a number of parameters and criteria that go into selecting a site. But we know generally where it's going to be, either in the Piedmont or Upper Coastal Plain region of one of the 2 states I mentioned. So hopefully their list that's been narrowed down, they come to a stand that is suitable for our project soon. I'm now going to turn things back over to Madison as she discusses the site climate profiles.
Okay, so I'm just going to continue with individual site descriptions, and starting off with the Florida site. Florida gets really hot in the summer, and the average temperature is around 80 degrees in the summertime, and they have pretty mild winters with an average in the low 50s, and the average low is above freezing for all months. The Florida site traditionally gets most of its rainfall in the summer and winter months, and limited rainfall in spring and fall, and you can see the distribution on the graph. The Oklahoma site gets very hot in the summer, averaging in the high 70s or around 80 degrees, and the average lows are below freezing in the winter. The Oklahoma site traditionally gets most of its precipitation in the spring and fall months and limited rainfall in the summer and winter, so kind of the opposite of the Florida site. And the Virginia site has averages in the mid-70s during the summer, but winters are relatively cold with 4 months where the average low is at or below freezing. Average monthly precipitation for the Virginia site is more uniform relative to the other sites and averages between 3.2 and 4.3 inches per month. This slide shows a comparison of temperatures and precipitation among the 3 sites, and the Florida site has the highest temperatures and the most rainfall, followed by Oklahoma, and finally the Virginia site. And from the earlier figures, you can see that the average monthly temperature and precipitation fluctuations are different among the sites. So we really have a range of climate on these 3 sites.
Okay, for the experimental design, as has been mentioned, we've got 4 locations. It's a randomized complete block design at each location with our 2x2 factorial of treatments. The control will be an ambient through-fall with no fertilization. Our fertilized treatment is designed to eliminate any nutrient deficiencies with a full spectrum of additions, 200 M, 25P, 50K, plus a micronutrient blend. The through-fall exclusion will be removing 33% of the through-fall, will be captured and diverted off the treatment plot, and then the final treatment combines the fertilizer and the through-fall exclusion with, as mentioned before, 4 replications at each site. The plot design size of the treatment plots will vary, and this is based on tree stocking. We wanted to have at least 30 measurement trees so we could get a good diameter distribution. The treatment plot extends outside the measurement plot by at least 20 feet on all sides, and we have an additional untreated buffer between each of the treatment plots of 40 feet to make sure we don't get any bleed of the fertilizer treatments from one treatment to the next. We've run into a few issues on the through-fall exclusion design, as in, 1, how to get the cost down within our budget, and 2, what materials to use, and how to minimize environmental impact of these exclusions beyond just getting the rainfall off the plot. We've pretty well settled on a plastic material called Polyscrim 12. It's 12 mil plastic that is actually 2 6 mil layers laminated with a string grid in between, as you see in the small photo on the left. It's very clear, although it looks opaque from the angle that I shot that picture on the top. But it's very tough. It's got a 48 to 60 month exposure rating in full sun. So I think the folks with the company I've been working with feel certain that it will hold up for the 5 years at least for our project, given that we're going to be under partial to full canopy by the end of the study. As far as the environmental impacts, we want to look at reflected radiation, air temperature and soil temperature effects, and how do we minimize those. Whoa, I did something wrong. Hang on a second. There we go. We've also had an issue that we discussed about creating soil moisture dry zones directly under the exposures and trying to minimize that, particularly on the clayier site there in Virginia. That we had a wide area that we blocked all the through-fall off of, that would turn into a brick-hard clay. So we decided to use 2 narrow troughs and leave a gap in between, as you see in the picture and in the diagram, to allow some moisture to get in between the 2 troughs to the soil underneath, as well as lifting the troughs up at least 3 to 4 feet off the ground to allow airflow and moisture to rain to blow underneath. We also tried a couple other designs as far as holding the plastic. One was using this crab line in the center of the material, the center of the exclusion, to hold the plastic, and that didn't work as well. We might could try a little bit more to come up with something that worked better, but I think for making the structure stronger and allowing better attachment of plastic, we're going to stick with using 4 2x4s, the length of the plot. And I've already got the plots laid in on the Virginia site, as you see here in the map, with the treatments identified. We've pretty well used most of this site. I think the footprint of the plots and the buffers takes up 12 to 13 acres. And as far as measurements, we're going to be collecting the standard inventory measurements of height, diameter, crown width, and height to live crown for the trees in the measurement plot. We'll also have weather stations installed. One will be on a tower above the canopy to measure above canopy rainfall and net radiation, as well as air temperature and humidity. We'll also be measuring soil moisture and soil temperature in each of the plots, as well as carbon balance and water balance. So with that, we thank you, and we'll open it up for questions.